Alright, this video works through course pack page 621. It examines the pressure vessel, thin-walled pressure vessel, that is the same dimensions and construction as the one that we used in the lab. That is a nominal diameter of 9 inches. The thickness is 14 gauge sheet. So a thickness of 0.0747 inches. A low carbon steel with a yield strength of 50,000 psi. And we want to solve the problem of what is the pressure at which yielding is predicted using both the Tresca and von Mises failure criteria. So to use a failure criteria, we first have to figure out what the stresses are. We know that for a thin-walled pressure vessel, we know that the hoop stress is the pressure times the radius over the wall thickness. And we know that the axial stress in this cylindrical pressure vessel is the pressure times the radius over 2 times the thickness. Because we know that this hoop value is the larger value, we can sort of jump to the fact that we know that that's going to be sigma 1. We also know that both of these values are going to be positive numbers because both of them are tensile if we're pressurizing this structure. So we know that this is sigma 2, and we know that our sigma 3 has to be 0. We would end up coming to the same conclusion if we just arbitrarily called this our sigma x, this our sigma y. We would have some number. This would be 2 times that number. And we know that sigma z is 0. We reorder these in terms of sigma 1, 2, and 3. This becomes sigma 1. This becomes sigma 2. And this becomes sigma 3. So getting our values for our principal stresses. Our first principal stress, the pressure times the radius times the thickness, which is our unknown that we're trying to solve for, times our 4.5 inches over the thickness, 0.747. And that ends up being $60.2 P. Sigma 2 PR over 2T. This is the same other quantities but half, so 30.1 times the pressure. Then we know that the maximum shear is equal to the first principal stress minus the third over 2. Well, the third is 0, so 60.2 P minus 0 over 2 is in fact 30.1 P, which incidentally is equal to the second principal stress in this case. Alright. So we know our max shear value is 30 times the pressure, and we're first going to look at our maximum shear criteria. So max shear failure criteria That is that our factor of safety N is the tensile strength of the material over 2 times the maximum shear. And we have to think about what that factor of safety means. We were asked, find the pressure at which yielding is predicted. Well, you expect yielding when your factor of safety is 1. So N equals 1 when yield is, when failure by yield is predicted. So we can substitute our expression for the max shear in. So factor of safety equals the tensile strength over 2 times 30.1 times the pressure. We know that N is 1. We know the yield strength is 50,000, and this is 60.2 times the pressure. Solving for the pressure, we see that the pressure is 830 psi. Alright, so now leaving that, if we use the same loading situation and we look at the von Mises criteria, so distortion, energy, or von Mises, we need to find our sigma prime, which is the first principal stress squared minus the product plus the second principal stress squared, the square root of that quantity. Well, in this case, those quantities are the pressure times the radius over the thickness for the first principal stress minus PR over T times PR over 2T for the cross product term, and then PR over 2T quantity squared. Alright, taking out a P squared R squared over T squared, we can say that that is the square root of PR over T squared times 1 minus 1/2 plus 1/4, and we can also say that that is the square root of PR over T squared, and 1 minus 1/2 plus 1/4 is 3/4. We can simplify that further by taking the square root of the squared, so the PR over T times the square root of 3/4, or this von Mises stress is the square root of 3/4 times PR over T. Our pressure is our unknown, so we have the square root of 3/4 times the radius over the thickness times the pressure. And for the von Mises criteria, we have that the factor of safety is the yield strength of the material divided by this von Mises stress. So again, failure is predicted when the factor of safety is 1. The strength of the material is 50,000, and this number here, the coefficient of the pressure, simplifies to simply 52.17 times the pressure. So that's the sigma prime, the von Mises equivalent stress. And so this ends up telling us that the pressure is 958 psi. So we have a little bit of, again, a more conservative result over here with the Tresca criteria. The max shear stress says that the pressure where you expect failure is 830. The distortion energy, or von Mises, says that you expect failure at 958. And if you go back and look on the actual pressure vessel itself, you see that the tank itself has a specified operating pressure of 160 psi. So very roughly, if you look at about 900 over 160, that gives you an actual practical factor of safety of 5 or 6, which is pretty typical for pressure vessels. Typical value for pressure vessels.